This is my Supermicro motherboard box. Alright, as the title implies, it's a 2-for-1 because it's basically the same motherboard. It is literally the same motherboard with different stuff soldered on it. I like it. Supermicro does things different, and yet the same. Let's take a look. So Supermicro's rear layout is really nothing remarkable. We have 4 USB 3 ports. Okay, that's pretty cool for an EPIC system. A lot of the time, EPIC, you don't have quite that many. You do have a 30-pin header for the front panel as well, so there's no USB-C or anything like that here. Why do you need USB-C on a server? We have 2 onboard 10 gig NICs. This is our Intel X550 dual 10 gig interface. And then we've got our 1 gig IPMI interface for remote management. Got an RS-232 serial, which could be great for an uninterruptible battery backup. And then of course our VGA header. This will work perfectly fine in a 1U chassis or a 2U chassis. Supermicro gives you some options. Now if you're looking at these two motherboards, they look almost identical. We've got an exactly identical PCI Express slot layout, identical M.2 layout, but what's different is over here on the side of the board. And actually there are other versions of this board that have even more differences. So this side of the board is a Slim SAS X8 connection. So there's 8 lanes of something here in this connector. PCI Express, SATA, you have to check the manual. Just when you see that, you don't automatically know. And then nothing is populated here or at the bottom edge of the board. There's also a lot of solder holes here. This is a BGA, a receptacle for a BGA controller, and then there would be more connections here for onboard serial attached SCSI control, which is nice. Supermicro realizes that even though you might be buying 2nd or 3rd gen EPIC to install in these motherboards, there is a lot of serial attached SCSI equipment still in the enterprise, and serial attached SCSI is not something the processor can directly support. It is pretty genius of AMD to make it so that the lanes can operate in PCI Express mode or the much slower and older and more backward SATA mode. But you've got 128 PCI Express lanes, and this is about cost minimization, so you just plug it in and you're good to go. It's a little more obvious when you look at it with this connection. Notice that one of our 2 connections is gone. Then we have 2, 4, 6 SATA connections. Oh, 8 down here at the bottom. These are disc on module. They're orange. They'll support power delivery, something like that. So it's pretty nice. Disc on module is pretty cool because you can put your server operating system there, and it'll live on a module that's out of the way and doesn't use any of the other connectors. Not your M.2, not anything else. These M.2s are set up for 80 and 120 millimeter M.2s only. If you need to use a smaller M.2, you'll have to use a plastic adapter that'll make it a little larger. 110 millimeters, plenty of clearance. I could run another 110 millimeter over here, or the more pedestrian 80 millimeter, totally fine. That's identical on both boards. It's just a question of where you've got your standoff located. It's plastic, it's removable, so you should swap it before you install your motherboard, but otherwise you're good to go. This is the H12SSL-I Rev 1.01, and this is the H12SSL-NT Rev 1.01. And actually, if you look at the actual printed circuit board and the markings on the circuit board, these circuit board markings are exactly identical. Another feature of Supermicro motherboards is there's a law in California that says you can't reuse any password. So these motherboards have a pre-generated password for the IPMI, unlike other vendors that make you pick a password on first use, which is maybe not good if you plug the management interface into an untrusted network because somebody else could happen along and then set whatever password they want. Well, in this case, on this board, the password has been set. It's there. It's on the sticker. Same with this one. It's there. It's on the sticker. It's pre-generated. This motherboard does require dual 8-pin power connections for the CPU. And for the power supply, we're going to be using the Be Quiet Pure Power 11 FM. It's a new power supply from Be Quiet. It's 1,000 watts. Our CPU and our motherboard is going to use well over 300 watts of that, but that gives me 600 watts to play with. Do you know why I like this power supply? Because it's inexpensive for what it is. 1,000 watts, it's quiet, it's plenty good enough for server processors, and it's got plenty of connectors. Also, I'm really tempted by Sliger's new rack mount cases. They've got 3 and 4U for servers just like this. Really tempted by those. I haven't ordered any yet. If you see one you like, let me know in the comments. Probably can build something around these. There's 15, 20 inch depth. I think it'll work well with these motherboards. I'm working on a very special build for an open source project. I don't want to give it away too much just yet, but I'm looking at both of these motherboards as a kind of way to deal with the project. And the interesting variable here is it more or less headache to just go with the SATA connections on this board, or can I use this SlimSAS X8 SF? It's got an SFF number that it's 8 lanes, but is it less headache to use this breakout connector and get something done that way? I have not had the best luck with PCI Express 4 breakout cables. If you follow the channel for a long time, you'll know that I usually use an add-in card for my PCI Express U.2, and that's nice because it moves my PCI Express U.2 drive physically close to these PCI Express 4 expansion slots. There's no opportunity for signal degradation. When we run things through a cable with PCI Express 4, really doesn't work all that well. We're just now getting enthusiast riser cables and right angle cables that will allow you to use a graphics card, in a right angle configuration in your tempered glass, side panel gamer case, and those cables just barely are good enough for PCI Express 4.0. So when you need some truly server grade PCI Express 4.0 stuff, it can be a little dicey, it can be a little problematic. The other variable that I'm testing on these motherboards is 280 watt power delivery for SP3 processors. If you didn't catch the review, I've done some reviews and testing of the Milan X, 768 megabytes of L3 cache. Oh, look at that. This is basically twin motherboards. Do you have something planned with the 768 meg EPIC CPUs that have 768 megs of L3 cache? How many times can I tell you that it has 768 megs of L3 cache? Those CPUs are incredible. Yeah, well, maybe, probably. Something magical's going on. Maybe we're building a cluster. Maybe we're building an open compute cluster. I don't know. You need more than 2 nodes for that, though. But then I've got some 7763s in addition to the 77. Oh, I've given it away. Well, I don't know. None of that is set in stone yet, but we'll see. Both of these motherboards feature 6 4-pin fan headers. I would have liked to see maybe a fan header toward the bottom, or maybe the bottom front edge of the motherboard. That would make my life a little easier in terms of a rack mount configuration, but hey, 4 connectors right here, I can't really complain too much. I might have also liked to have had a right angle 30-pin connector for my USB. Having all the connectors right here pretty much means that anything that's going to go in this bottom slot has to be a single slot peripheral. Otherwise, it's going to block all the connectors at the bottom edge of the motherboard. Not a big deal. That USB connector is basically the only one I really care about. I will also tell you, if you plan to run this motherboard with a bunch of GPUs, whatever crazy thing you've got planned, you definitely want to disable the built-in VGA, especially if you're going to run Windows. Windows really seems to be on the struggle bus with the ASpeed 2500 plus add-in GPUs. You can use this jumper on the bottom edge of the motherboard to disable the built-in VGA, and things will work a little bit better from the Windows side. If you're running Linux, it doesn't really matter. The other thing is power. If you're going to run, 2 or 4 GPUs, they can pull up to 75 watts through the PCIe slot. There's not an extra power connector on this motherboard for supplemental PCI Express power the way that we've seen on other EPIC motherboards that, could be used for workstations or could be used for something else. In that case, you're going to want to make sure that both of your 8-pin power connectors are connected. Each one of these connectors can handle 800 watts, but Supermicro's design here seems to be sort of planning that CPU 12-volt power plane is going to be shared a little bit with some of the other peripherals, at least if you're using both of these 8-pin connectors. I have not decided on the memory configuration yet for this particular project. It is always nice whenever you can fully populate it. I mean, EPIC is 8 channels. You want to give it its best shot for success, give it 8 sticks of memory. We can do that. That's not a problem. EPIC will run with 4 or 6 sticks of memory in addition to 8 with, there's a little bit of a performance trade-off if you do that, especially when we're talking about the 64-core processors. I do like to see that this platform has matured. There are a lot of bug fixes in, and 3rd gen EPIC has been an even smoother lifetime than 2nd generation EPIC. When EPIC first launched, codenamed Naples, those were good CPUs. It was a good approach. It's perfectly fine. I'm still using a Naples system, a Naples-based system, a dual processor system, dual 16 core. It's nice. It's still nice. The trick with that system is you needed to populate all the memory channels. That still kind of holds true with Rome and Milan when we're talking about the higher end CPUs, but it's less necessary than it used to be. I'll say that. The transition from Naples to Rome and then the teething with Rome, retrospectively, not bad. And now support from AMD and partners like Supermicro for third generation EPYC have been very, very good. Third generation EPYC is basically mainstream when I'm making this video in 2022. I mean, it's been out for a year plus, and it's very well supported, and it's very well supported. AMD is basically selling every Milan chip that they can possibly make, so it's pretty exciting. I did some quick testing with the Phoronix test suite. Basically everything worked as I expected. AMD EPYC Milan has some really cool features like encrypted memory and nested page tables and other virtualization features. I quickly ran through some tests on those. Didn't find any misimplementations on this motherboard. Do be aware that there is kind of a transition happening with message signaled interrupts or software programmable interrupts, advanced programmable interrupt controller stuff, and to take advantage of the lowest latency, least overhead interrupt remapping for virtual machines, you will need Linux kernel 5.18 on this third generation EPYC platform. It was a little rocky there because some people expected to be able to do, like say, AVIC PCI Express remapping, and that feature was basically broken for a little while. Not every motherboard vendor supported it at every generation. You might have to use an older BIOS or an older something. It was wasn't fun. We were hanging out on the level 1 forums dealing with some of the fallout from that. But X2 APYC and the next generation interrupt remapping stuff in kernel 5.18 is there and working, at least in my early testing. But that's maybe something that I should do a separate video on, because some people are just getting into the, wow, we really can accelerate how a virtual machine feels if we can do the low overhead interrupt remapping. It's like, yeah, turns out need that for gaming and GPU pass-through as well, because it makes the machine feel a lot better, feel a lot more snappy. So looking forward to doing those experiments with these boards as well. I'm one of this level 1. This has been a quick look at these EPYC server motherboards from Supermicro. I don't really find a lot to complain about here. I like the onboard 10 gig, I like the feature set, and I like the fact that I can get the motherboard with whatever connectors and onboard peripherals I want pretty readily, especially in this supply chain situation. So good job, Supermicro. All right, if you have any questions or you want to do a build or do some tests or see me run something with your workload, well, write it up for me. Join me in the forums at level 1. I'm Wendell, I'm signing out, and I'll see you there.